Today we are going to review what we talked about with solving equations that have a square root. The first thing we're going to look at is the graphs that we were talking about. So it says, on the graph to the left, the function f of x equals square root of x plus 2 is graphed in red. Now, foolish me did not remember that I cannot print in color. So this is the graph of square root of x plus 2. And the function x minus 4 right here would have been graphed in blue if this was in color. So the question is, use the graph to explain why x equals 7 is a solution to the equation square root of x plus 2 equals x minus 4, and x equals 2 is an extraneous solution. So notice that there's actually two different parts. The first part being explaining why x equals 7 is a solution. The second part being explaining why x equals 2 is an extraneous solution. So to answer the first part, why is x equals 7 a solution? Well, we know that two graphs are equal to each other when they intersect. And if we look at their intersection, it happens at x is equal to 7. So the answer to the first question is, well, x is equal to 7 is a solution to the equation because the two graphs intersect at x is equal to 7. Well, that's not the full answer. The second part of the question is, why is x equals 2 an extraneous or extra solution? Well, if we look at x is equal to 2, we'll notice that the graphs do not meet at x equals 2. So x equals 2 is an extraneous solution because the graphs do not intersect at x equals 2. And in case you're wondering, well, you know how we've always talked about, well, when you take the square root, you get a plus and a minus. Well, in this case, if we actually did consider that minus part, the graph would look like this. And if you notice that x is equal to 2 would have intersected that second half of the graph. Problem being, this now fails the vertical line test, and this is not a function. So that is why we actually do not include the bottom half of the parabola, even though it would get us that second solution. Now let's move on to the equations. So for the equations, all we have to remember is that the inverse of taking a square root is squaring. So to get rid of this square root, all we have to do is square both sides of the equation. That eliminates the square root sign on the left and gives us an x squared on the right. And from what we remember about factoring, anytime we have an x squared and an x in an equation, we want to make sure that we set it equal to 0. So I'm going to add x and subtract 12 from both sides and get 0 is equal to x squared plus x minus 12. At this point, all we have to do is our standard factoring and solving the equation to get our two answers. But like we found out the other day, we now need to test to see if these two answers are actually solutions. And the way that we do that is we plug them back into our original equation and see if we get a solution that actually makes sense. In this case, I get the square root of 16 is equal to negative 4, which the square root of 16 is positive 4, and that can't equal negative 4. So x is equal to negative 4 is an extraneous solution. Now when I check 3, I get the square root of 12 minus 3 is equal to 3. Square root of 9 is equal to 3, which actually works. So x is equal to 3 is an actual solution, whereas x is equal to negative 4 is an extraneous solution. Now let's move on to the next problem. Same thing, square both sides. X is equal to 8x squared. Set the equation equal to 0, and this time we are going to factor using our common factors, or that inverse of the distributive property. And now we say, well, x would have to equal 0, or x would have to equal 8, and we do the same thing. We plug in both of our solutions, and in this case, we actually get a scenario where both work. So we actually have two different solutions to this equation. Now, I'll tell you, on your practice sheet, there's actually one equation with two solutions and one equation with no solutions. So you always have to check both answers. Our final two problems are a little bit different because you'll notice that they actually have an n plus 2 on the other side of the equation. What that means is when we square both sides, we actually need to put a parentheses around the n plus 2. Well, on the left side, we still get rid of the square root, but on the right side, well, we got to remember what squaring something means. It means taking what's inside of those parentheses and multiplying it by itself. So what we get is 6n plus 19 times, or equals, n plus 2 times n plus 2, which means we got to distribute, or use FOIL, or use the box method, or whatever you're most comfortable with. And so, after we collect like terms, we get 6n plus 19 is equal to 4n plus 4, and then we do the same thing as before. We subtract 6n and 19 from both sides so that the equation is set equal to 0. Then we factor, use zero products to find out what our two answers are. And then we still need to check our solutions to make sure they actually work. Equals 5 plus 2. 49 is equal to 7. So 5 works. And negative 3. Square root of 1 is equal to negative 1. That is not true. So 5 is a solution, and x is equal to negative 3 is an extraneous solution. Let me do one more for you, just so you get the idea. Again, we square both sides. On the left side, that gets rid of the parentheses, and on the right side, that means we multiply a minus 6 by itself. Now we distribute. A times a is a squared. A times negative 6. Negative 6 times a, and plus 36. Set the equation equal to 0. Oh, I forgot to collect like terms, so let me do that first. 7a minus 54 is equal to a squared minus 12a plus 36. Now I set the equation equal to 0. And I factor. So we have a is equal to 9, or a is equal to 10. Once again, we plug in both of these. 963 minus 54 is equal to 9 minus 6. Square root of 9 is equal to 3. Hey, that works. Awesome. But as I said earlier, we still always need to check to make sure that both end up working. And in this case, we actually get 4 is equal to 4, so we actually have two solutions here. We have the solution of A is equal to 9 and the solution of A is equal to 10. So long story short, make sure you check both answers because both of them could be true or both could be extraneous.